Okay. Hi, everyone. My name is Francesco, and today, along with my colleague Thomas, we share with you what we learned from using Apple's UI testing framework in Subito. We provide some good reasons to use it, and we present a set of custom tools we developed to take advantage of UI testing even more. Subito is the leading classified marketplace in Italy. We started in 2007, and as of today, we count more than 8 million unique visitors per month. The current iOS app is based on a 2013 rewrite, and so the code base is 5 years old. On the App Store, we currently have around 130,000 ratings with an average of 4.7, and last year we were awarded by Apple as one of Best of 2017. We care a lot about quality and user satisfaction, but this is not always easy when dealing with a lot of legacy code. The practice of testing and the tools we're going to show you helped us a lot to accomplish this goal. Looking back 2 years ago, when we decided to adopt this framework, our biggest problem was that our development was too strictly tied with manual testing. App releases were becoming a real nightmare. Everyone in the team was involved into a manual testing phase in which we executed a giant test plan on each type of device. The third-party tools available at the time were not giving us reliable results, so we were not confident of replacing manual testing with them. And then suddenly, on a 2015 June day at WWDC, Apple presented its shiny new UI testing framework based on the existing Xcode. And at the moment, we immediately decided to jump in because, it's the official tool and just works, right? No. We were wrong. The first version of the framework was far from being stable. But we decided to stick with it, opening a lot of radars, and in the process, gaining some experience in the field. 2 years after, we can say that we are happy with our choice. Apple has evolved the frameworks, adding improvements and new features, and release after release, it's pretty clear that UI testing is something Apple is investing on. Today, the framework has reached a great level of stability. And we believe that UI testing has become a valuable asset to reduce manual verification and to help achieving quality for our app's users. Okay, but why do we believe this? We want to give you today at least 6 good reasons to give UI testing a chance to become part of your own development process. Number 1, get rid of manual testing. As I said, this was one of the main problems we had before adopting UI testing. The problem with manual testing is that it's a long and tedious task, and for these reasons, it also turned out to be very error-prone. Implementing your test plan with UI test can literally save you hours of work for each app release. And this, together with the release automation, allowed us to go from one release per month to one release every 2 weeks, and to have a single person responsible for it instead of the entire team. Reason number 2, UI tests are implementation independent. A test case interacts with your application in the same way a real user does. It has no notion about implementation details, and this allows you to refactor large portions of your code base without having to modify your test. And this becomes super useful when dealing with a lot of legacy code that lacks a proper testing coverage. You can provide the coverage from the outside, and then you can refactor the inside. And during these years, we used this technique to port large portions of our code base from Objective-C to Swift. 3. Tests are simple. Testing code is really simple to understand. Even if you don't have a good knowledge of the code base, you immediately get the idea of what the test is doing. And also, writing tests is rather simple, so it's really easy to start after getting the basics. Testing code is also usually very compact compared to the amount of code under test, so you can test a lot with little code. To give you a figure, we estimated that in our code base, A single line of UI test covers approximately 6 lines of app code. Reason number 4, it's the official tool. Although there are lots of alternatives to the framework that Apple provides, we believe that there is a strategic risk on relying on a third-party tools that might eventually stop being supported or that breaks due to some changes made by Apple. This, of course, does not only apply to testing, but overall we are trying to drop external dependencies when possible. 5. Leverage runtime sanitizers. As you know, Apple recently introduced in Xcode a number of runtime tools to help you find very subtle problems in your applications. Some of them are the thread sanitizer, the core data context checker, and the other sanitizer. You enable them with a single click on your app scheme, and you get full advantage by just running all your tests. And this really adds an extra level of quality to your application almost for free. 6 and last, monkey test. We were recently facing a bug that has a serious impact on our quality of service. The issue was caused by a third-party SDK that was crashing the app in a way that was very difficult to replicate. It just occurred randomly. After several attempts to manually reproduce the crash, we decided to write a set of monkey tests which were repeating thousands of times the action we believed was causing the issue. Indeed, after letting the test suite run for a while, the crash finally occurred. Using monkey test helped us to reproduce the bug and to finally fix it, bringing our quality of service back on track. In addition to that, we also ended up having an automatic test suite to verify that the problem was actually solved. While this can be considered as a kind of edge use case, it shows us a completely different usage scenario for UI testing. So we believe that can be interesting also for some of you. Okay, so now Thomas will present you the main limitations we found in the UI testing framework and how we managed to overcome them to make this tool even more powerful.
So, it is interesting to note that it definitely takes some time to appreciate and find 6 positive aspects about this kind of testing. You will probably wonder if all the hassle in adopting them makes any sense up until the first regression gets caught, and that will be, of course, a rewarding and memorable moment. On the other side, it is really clear from the beginning what is less than ideal with this technology. So we spot at least 3 main pain points, which over time we also manage to overcome. So the first issue is that they feel limited. When I look at the UI word in the name of this technology, I somehow naively imply that they should allow us to test the entire user interface of an application. But that's actually not the case. In fact, it only allows you to test the parts of an application that can be reached by using gestures. This can, of course, significantly reduce the parts of an app that can be tested. Just as an example, think of a path in your app that is triggered by a particular network response or a specific setting in your user defaults. So this limitation is due to the fact that the testing code lives in a completely separate process, actually a completely separate app called the runner app that is responsible to execute your testing code and interact with your application by applying gestures. And like any other iOS app, it has no means to access other applications' code. So in other words, the framework that Apple provides only allows pure and simple black box testing. It tests an app from the outside without any knowledge or access to its internals. So we designed a library that sits on top of XUI test framework to overcome this limitation. The library is called SBTUITestTunnel, is open source and available on GitHub. So the idea behind this library is really simple. We establish the missing connection between the tested app internals and the testing app by installing an HTTP server on the tested app, which allows us to dynamically inject changes during the execution of our tests. The interface of the library is really very simple and just boils down to a single subclass of XCUI application. The nice thing is that you continue to write plain and simple XC test cases, but with the added features, you are now able to reach almost any part of your app. But what are these added features? So the library offers a large set of functionalities that can be used from simple use cases to much more complex ones. The features that are probably most useful are those related to network and application data. You can very easily play around with network requests by selectively throttling, stubbing, monitoring, or even rewriting the request made by your application. So simulating, for example, a network error is really a one-liner in your test case code. It's just as easy to modify user defaults, update keychain values, or even upload or download files to your app's file system. And this can be, for example, useful to inject a database with known values at the app's startup. So if you tried out UI testing before and somehow felt they weren't powerful enough, we believe you should definitely give them a second chance together with our library. Now let's see the second pain point. When running UI tests out of Xcode, like for example in a continuous integration environment, it's difficult to quickly find the cause of a failing test. The outcome of a test session is a single large plist that contains all the information you normally see when browsing results in Xcode. And with that, I mean it contains the list of all your test cases, test suites, the single actions, the execution times, the path to your screenshots, and so on. So this file can significantly grow in size as you run more tests. And as a result, it becomes difficult and time-consuming to determine the sequence of action that cause a test to fail. Instead, what one usually does is take the failing test and manually rerun it in Xcode again, and seeing from there what went wrong. But this is also time-consuming because you need to check out the branch, you need to compile the project, you need to run the tests, so this also takes time. We decided to develop another tool to parse and present test results in an accessible and simple fashion. The tool is called SBTUITestBrowser, is again open source and available on GitHub. As you see, it is a very simple web interface that visualizes your test results. So nothing too fancy at first sight, but it does, however, its job, letting you access the exact same information you see in Xcode, with the same hierarchy and support for screenshots directly in your web browser. The project that began as a simple plist to HTML converter over time evolved as we added more features. As of today, it is able to link a crash to the test that was running at that time by simply providing the path to the folder containing all your crash logs. We also integrated support for code coverage, and while it's really not that interesting to know which specific lines of your code are covered by UI tests, it can become very useful to focus on areas that are clearly uncovered. But the most important feature of our browser is that it has the entire history of your latest test. This means that it can provide statistics like, for example, the average execution time of a test. And this will become key in what we will see next. Before that, let's get to the last and biggest complaint about UI tests. They are slow, like really slow. It takes time not only to execute a test, but also to start it. And that to a degree that for short tests, these two times can become comparable. So in Subito, we reached now over 300 UI test cases for a total execution time of approximately 4 hours per device. That's pretty obviously an unacceptable amount of time for anyone planning to launch these tests more than once in a day. So besides opening radars, asking Apple for improved execution times, and as some of you may know, there are significant improvements in this area with Xcode 10, we worked in the only possible direction, which is parallelization. We managed to develop a dispatching engine that is able to split and run tests over multiple physical machines and merge the results together once tests have completed. Parallelization is also done per node, allowing you to specify how many simulators to run at once. Scaling the system is as easy as adding a single line to a JSON configuration file. Now, let's see in detail how this is achieved. So, the steps involved explained in plain English are rather simple. I need to take my project, I need to compile it, I need to extract the list of tests, execute all the tests on the available nodes, and then merge the results back together. By leveraging Xcode build and our test browser, it's really just a matter of putting things in the right order. But as some say, the devil is in the detail, and of course in practice, things are a little bit more tricky, because we also try to optimize this process as much as possible. For example, we perform compilation, which is a computational intense task, on a single node, the fastest in our farm. And then we distribute the resulting XCTest bundle to the remaining nodes. The XCTest bundle is a folder that is produced by Xcode build, which contains all the data required to execute your test without compiling a project. Given that compilation takes some time, we'll also do a bunch of things in the meantime, like, for example, extracting the list of tests in our project. And for each test, we will request the average execution time to our test browser. This, of course, allows us to equally distribute the total execution time on each node. We will also boot and prepare simulators, which is also a time-consuming step, to be able to start our tests as soon as compilation has completed. Missing runtimes or simulator devices are installed if needed, so that you really do not care to preset up your nodes in any known state. So, once compilation has completed, we just need to let Xcode build run the test on all the nodes, and then wait for them to complete. So the outcome will be a set of test data, and with that I mean the plist, the attachments, the various logs on every single node. We will copy all this information to a single node responsible for collecting them. So are we done? Yes, but only thanks to another unique feature of our test browser, which is the ability to merge different results based on some predefined rules, so that when we connect back to our test browser interface, we will see a list of tests as if they were run on a single machine. So the time saved running the test this way goes pretty much linearly with the number of simulators. And using our dispatching engine allowed us to cut down the execution time down from the aforementioned 4 hours to approximately 15 minutes. While this is still not a real-time feedback, it's acceptable in our current development flow. However, the perception of acceptable is of course subjective. The good news here is that as soon as the total execution time of your tests exceeds your acceptability threshold, you just need to add more nodes. So This last piece of our UI testing puzzle is still not open source, but we will plan to do so soon. You may ask yourself how this compares to the parallelization that was recently introduced in Xcode 10. We believe that our solution has still its advantages. Apple parallelizes tests on a single destination, requiring top-notch hardware to run several simulators at once. And the rule of thumb is that you will need one core per simulator. So, say you plan to run 10 simulators at once, you will need a 10-core machine. Our solution scales independently of hardware specification. And as a matter of fact, we are building up our testing farm reusing our company's obsolete machines. So, the result is shown in this video where you can see our farm in action. Thanks for listening. I hope you enjoyed the talk and that we managed to persuade you to give UI testing a chance. One more thing is, if this sounds interesting to you and you're willing to join one of the most interesting tech companies in Italy, please make sure to come by at our desk and talk with Silvia and Lucia. So, thanks again.